Welcome to Cosmic Wonders. Today, we're doing a deep dive into something truly fundamental, the lives and deaths of stars. Those lights in the sky.
Yeah, it's amazing to think about them. You
Yep.
look up, see all those points of light.
And wonder where they came from, how they work. I mean, the scale is just immense.
Oh, absolutely. The universe is, well, packed with them. Estimates go up to a septillion stars, maybe even more.
A septillion, that number is almost meaningless. It's so big.
Right. And just in our own galaxy, the Milky Way, we're talking hundreds of billions. Our sun is just one, a pretty average one at that.
Okay, so billions and billions. Where does star number one or star number septillion actually begin?
It all kicks off in these gigantic clouds, really cold, really spread out, made of gas and dust.
Molecular clouds.
Exactly, molecular clouds.
Huh.
Gravity is the key player here. It starts pulling denser clumps of this gas and dust together.
So gravity makes them collapse inward.
Precisely. And as they collapse, the material in the center gets squeezed, heats up a lot.
Hot enough to ignite.
Eventually, yes. That's when you get a protostar. Think of it like a stellar embryo, a star being born. And they often form together in these big groups.
The stellar nurseries.
Stellar nurseries, yeah. Clusters of young stars lighting up.
So once they're born, they settle down into a long phase, their adulthood.
That's the main sequence. It's the longest part of a star's life. This is where the magic happens in the core.
The fusion.
Hydrogen atoms smashing together, fusing to form helium. That process releases a massive amount of energy, the light and heat we see.
And our sun's doing that right now.
Yep, smack dab in the middle of its main sequence phase. But, how long this phase lasts depends completely on the star's mass.
Ah, right. The bigger they are, the harder they fall, sort of.
Kind of. Massive stars burn through their hydrogen fuel incredibly fast, maybe just a few million years.
Wow, only millions.
Yeah, cosmically speaking, that's short. But smaller stars, the little red dwarfs,
Yeah,
they sip their fuel. They can last for trillions of years.
trillions. That's hard to grasp. Okay, so eventually they run out of hydrogen in the core. What then?
That's the turning point. The core runs out of hydrogen fuel, so fusion stops there. Gravity takes over, the core shrinks and gets even hotter.
And the outer parts?
They swell up hugely. The star expands dramatically. What happens next, the really final stages, that again depends on the mass. Low mass or high mass.
Okay, let's take our sun, medium-sized. What's its future look like?
Our sun will become a red giant. As the core contracts, it gets hot enough to start fusing helium into carbon.
So a new fuel source, temporarily.
Right. But the outer layers keep expanding, puffing outwards. They might even swallow Mercury and Venus, maybe Earth. Eventually, though, those outer layers drift off into space.
Forming what?
A planetary nebula. These beautiful, glowing shells of gas we see through telescopes.
And what's left behind?
Just the core. A very hot, very dense core called a white dwarf. Mostly carbon and oxygen. It doesn't fuse anymore. It just sits there slowly cooling down over billions, trillions of years, fading away.
A quiet end, then, relatively speaking. What about the big ones? The massive stars.
Oh, they go out with a bang.
Yeah.
A huge bang. Because they're so massive, their cores get hot enough to fuse heavier and heavier
Well,
elements.
for helium?
Carbon fuses into neon, then oxygen, silicon, all the way up the periodic table until you get iron.
Iron. And that's the end of the line.
That's the absolute end for fusion producing energy. Fusing iron actually consumes energy. So when the core becomes mostly iron, there's nothing holding it up against its own immense gravity.
And it just collapses.
Catastrophically.
Yeah.
In a fraction of a second, the core implodes, bounces back, and triggers this unbelievably powerful explosion.
A supernova.
A supernova, one of the most violent events in the universe. It shines brighter than an entire galaxy for a short time.
Incredible. What does a supernova leave behind? Does anything survive?
Sometimes. The collapsed core can survive, crushed into something new. If the original star wasn't too massive, it becomes a neutron star. An object maybe the size of a city, but with more mass than the sun. Incredibly dense. Protons and electrons squeezed into neutrons.
And if the star was really massive,
Then gravity wins completely. The core collapses past the neutron star stage, crushing itself into a single point, forming a black hole.
where gravity is so strong, nothing escapes.
Not even light. But the supernova itself does something vital. That explosion blasts all those heavy elements. The star created the carbon, oxygen, iron out into space.
Seeding the cosmos.
Exactly. That material mixes with gas clouds and becomes the raw material for the next generation of stars, planets.
And maybe even life. All that carbon and oxygen.
Precisely. It's this amazing cosmic cycle of birth, life, death, and recycling. We really are made of stardust. in a very literal sense.
That is quite a thought to end on. The universe constantly rebuilding itself from the ashes of old stars.
It really puts things in perspective, doesn't it? The time scales, the connections.
It certainly does. Well, thanks for taking us through the amazing stellar journey.
Always a pleasure. It's a fascinating universe.
Thank you for listening to Cosmic Wonders.